All yours, Seth.
Okay. Hello, everybody. I'm Seth Shostak, and welcome to the Drake Awards, an annual event that celebrates, well, people who work in the field of SETI or something related, and is named in honor of the pioneer of SETI, of course, Frank Donald Drake. The Drake Awards have been going on for a couple of years now, and so we do have alumni. We will introduce those soon, and you will also, of course, hear from the winners of this year's Drake Award. There is plenty of opportunity, by the way, well, at least some opportunity, for you to ask questions of the people you see before you on the screen, assuming you can see them. You probably can't see them yet. There's Paul Horowitz there. Paul Horowitz is at Harvard, and not only does he do SETI, but he also builds equipment to do SETI. Paul is maybe known to some of you of your electrical engineering majors because his textbook, The Art of Electronics, is the standard for that field. I assume that it's still the standard, Paul, or did they take it off the shelves?
I hope it's still the standard.
Okay, there you go. We also have Vicky Meadows. She's up in Seattle. Vicky is an astrobiologist, originally, I think, from Australia, Vicky. And what are you working on these days, Vicky?
Oh, lots of things, and I'll talk about them in a little bit more. But we at the moment are working to support the Habitable Worlds Observatory by trying to understand how to detect signs of life on extrasolar planets.
Well, how about just going there? Okay. That would be convincing, although expensive. All right. And is there anybody else on here? SETI Institute, I don't know whether that's Steve Bordeaux. It might be. Steve doesn't seem to be inclined to show his face, although Steve is the man behind this event and many others that the SETI Institute holds, and he does a lot of the work. So, Steve, if you want to show yourself, I think you should feel free to do so. All right. I think that as soon as we know that the live component of this event is underway, because they actually have to physically move to another room. Once we have that, then we'll get right into the program. I'm not sure how I'm going to know whether that's true or not. It's miles away from where I'm sitting, so I can't tell. Steve, do you read me?
This is Beth. Yeah, I'm keeping an eye on what's going on, and Lee and I are communicating. So as soon as they're ready to go live,
okay,
I will let you know.
Well, since we have this this space here, Paul, you're retired, but that doesn't mean you're really retired. What? Tell us something about it.
Being retired is a chance to do what you really want to do. So fewer faculty meetings, fewer exams to write and then grade, which is as much work as taking an exam, probably worse. And it's just wonderful. So I've been heavily involved with SETI and also in writing successive editions of our electronics book. I have a co-author, and it's been terrific fun. But I was given a charge here of what to talk about, Seth. Can I run with that? The charge was speak about Frank Drake and also about what we're doing now. Can I go? Go ahead. Okay.
Yeah, I think all of us will probably say something about Frank Drake, but I doubt that there'll be much overlap. So please do. This is, it is the Drake Awards after all. But yeah. I think people would also, of course, be interested to know what you're doing there at Harvard.
Yeah. Okay. And in fact, at San Diego, Berkeley, and Caltech, we have a four-way collaboration. I'll get to that in a few minutes. Frank was a wonderful influence in my life. Oh, look what pictures changed now. We're at full screen. That's how nice. I got bigger. So how do we meet? It goes way back. So in the 50s and 60s, when I was a kid growing up, geeky kids, well, all kids, we didn't have internet. We didn't have cell phones. We didn't have computers. Communication. Occasionally you get something called a long distance call, and that was a call to arms. You had to come running because the Bell system was charging you several dollars a minute for the privilege of speaking with someone several states away. So what did geeky kids do in those days? You either took apart your car and tried to put it back together, or you did ham radio. At least as far as I could tell, those were the choices. And I wasn't in the car, so it was ham radio. And ham radio, it's kind of fun stuff. You get to build electronics, and then you get to talk to people at some distance away, sometimes halfway around the world. And it gets you thinking about long distance communication. Really, it's quite remarkable, just typically with tens of watts of radio frequency power, you can talk to someone halfway around the world. So I think the idea, and by the way, many radio astronomers and other physical scientists got their start through ham radio. I was down at Arecibo in 1978 doing a search SETI thing, and about a dozen of the radio astronomers and staff were radio ham. So they got pulled in the same way. My thesis advisor, Robert Pound, was a ham, big ham. Anyway, so basically the idea percolated in the back of ham's minds, me too. And then in graduate school, one of my roommates was taking a course by a guy by the name of Carl Sagan. He was a junior faculty member at Harvard at the time, and he was teaching a course called Intelligent Life in the Universe. This was actually the basis of the book that he co-wrote with Shklovsky called Intelligent Life in the Universe, and he was using that as a course notes. I wouldn't take it, but I sort of took it vicariously because my roommates were taking this thing. It was fantastic. I mean, you know, there's plenty of speculation in the business of SETI, but there's things that you can absolutely calculate, like how far you can communicate with a certain amount of power using a certain kind of antenna. And it made it completely plausible, in fact, absolutely a fact, that you could communicate to nearby stars. In fact, with the technology we have on Earth now, we could communicate with a star anywhere in the galaxy with the kinds of power and antennas we have, assuming that they're no more advanced than we, which is a very conservative assumption. So anyway, there was Sagan's course, and then the wonderful thing happened is Franck came to Harvard to give a series of lectures. They're called the Loeb lectures. They've been endowed, and all kinds of famous people have come and given them. And Franck gave a wonderful series of lectures. The first two were on radio astronomy and planetary astronomy and the kind of stuff that he specialized in. And the last one was about communication through space and SETI. And it was just terrific, just terrific. So when I was a faculty member, a few years later, I had a sabbatical coming up. And I wrote a note to Franck saying that I was interested. I wondered if I could look for life in Puerto Rico. He was head of the Arecibo Observatory at that point. And he got the joke and he said, sure. And how big a stipend do you need? You know, it never occurred to me that someone's going to pay you to do something as fun as a search for extraterrestrial intelligence. So that was really cool. He went down there and did the search and absolutely hooked on SETI at that point. This is the biggest telescope in the world, had some of the best instrumentation. And as a result, the search was the most sensitive that had been done in SETI up to that point. In fact, the sensitivity record stuck for about another 20 years before somebody did something more powerful than that. So that was sort of how I got to know Franck. And his influence on SETI, well, I'd say it's majorly. You know, he did the first real search in 1960 with the Project Ozma. He wrote the world's second most famous equation, it's said, the other one being, you know, E equals MC squared. I like Franck's equation better, actually. And Franck caused a swerve in a bunch of people's careers. I don't think I would have been doing SETI were it not for Franck. And Dan Wertheimer, who was a Drake Prize awardee several years ago, was similarly inspired by Franck. In fact, he likes to say that he was the only person in his group of I guess it was a computer club in Berkeley in the Bay Area, the only one who didn't become a millionaire, and it's all because of Franck. Franck's responsible for Dan's poverty. Franck was a wonderful guy. He was calm, always calm, generous, wise, and innovative. And I can't think of someone better to model myself after. Just a wonderful guy. Now let me just flip over to the other question. I guess I got about 2 more minutes. I hope I can take it. What are we up to now? So, as I said, we're involved in a project with UCSD. Shelley Wright, who we hoped would be here tonight, but she's unable, is the head of the project. She also won the Drake Award. In fact, the whole project is full of Drake awardees. And also involves Berkeley with Dan and Caltech with my former graduate student, Andrew Howard. And what we're trying to do is scope out a corner of the space of things you might look for that are not covered by the big searches, the Breakthrough Listen. So Breakthrough Listen is looking for radio frequency carriers, radio frequency pulses, and they're looking for optical continuous radiation, a spectral line, a laser basically. But what none of those searches are looking for is a short optical pulse. And there's good reason to think that that might be a very effective way to communicate. We could right now, in fact, for the last 20 years, we've been able to make a bright flash of light using our best lasers in combination with a telescope used as a beam director, a searchlight kind of thing. We've been able to make flashes of light, which seen from afar, seen from another solar system, another extrasolar planet, would be 10,000 times brighter than the light they'd see from our star during the time of the pulse. And that's a calculation you can do. Again, it's not speculation. You can do it. And basically, nobody's looking for that. And we decided that would be a really cool thing. And in fact, to cover the whole sky with it. So we came up with this crazy screen. And let me just show you a few pictures. I'm going to share screen. We practiced this before, so I got to find the right screen. And I think this is the one I want. Share. So let's see. My screen is loading. My screen is sharing. Can you see my mouse when I do this? Beth, could, yeah, okay. So this is one of about 4 pictures I'm going to show you. This is the idea we've come up with. Instead of using a mirror for a telescope, we're using a thing called a Fresnel lens. We were thinking mirrors, but there's a French scientist in our group by the name of Jérôme Moiya, and he's French, and so is the thing called a Fresnel lens here. And he said, dummies, don't use a mirror, use a Fresnel lens. And he's absolutely right. It's wonderful. And at the back end, this is the part I love. This is the electronics package here. And by the way, this picture, when I was doing PowerPoint, I discovered that PowerPoint these days wants to launch AI at you. So it gives you suggested titles. And so the title for this shows the telescope put together with the Fresnel lens in the front. The title for this one, you'll love this one, is, quote, a motorcycle with a side mirror. Now, I don't know how I came up with that. You know, AI has this mysterious mechanism and nobody can tell what it's really doing. And somehow this combination of light and dark reminded it of a motorcycle with a mirror. Anyway, here's the thing put together. Here's the electronics package here. You're seeing the top side, and the underside in this whole central square is peppered with little highly sensitive billionth of a second, nanosecond speed detectors. And here it is in this assembly with the shutter and everything else. So this is the thing we've been building. We have a few of these online, and we would like to put about 20 or 30 of these up in 2 separate domes, looking simultaneously at the same patch of sky. In fact, almost all of the sky, to look for these flashes. Here, I'll show you the next one. I'll show you what a Fresnel lens looks like, this thing at the front. Thought I was going to tell you. Let's see, how do I do it? I'm going to do that. There it is. Okay. Here's Shelley Wright, who's not here tonight, but here she is virtually. And she's holding a Fresnel lens in front of her face. And it behaves like a lens, but it's this very thin thing. And the AI of Microsoft PowerPoint labeled this one a person holding a circular object with a person's face. Well, kind of, but not really. It's a lens. Okay, so we built these systems. We've tested them in the lab. They can detect short flashes of light, but can they really work if you point them at the sky? And we were thinking, gosh, what we need is some satellite up there that's going to make flashes so we can test this thing. You know, we make a CubeSat, we put a mirror on the moon. What do you do? And somebody said, dummies, don't you know there's a satellite called Calypso? And Calypso is this thing here, which is intended to measure the atmosphere. This is sort of supposed to be a cartoon showing you how it's sounding the atmosphere by shooting a beam down and looking at the reflected light. So here's how it looks. It's got a telescope and it's got a laser, and it flashes light and makes little 20 nanosecond flashes, 20 billionths of a second, about 20 of them per second. And it hits the ground with about a 300-foot splash of light. And of course, it's not interested. You're not supposed to be looking at this thing. It's just looking at the reflection back from the atmosphere. Well, it's never going to go right over you because it's only hitting a few hundred feet at a time and it's sailing around the Earth. But it turns out that the laser isn't perfect, and a little bit of glint comes off to the side. So we pointed at the place this thing's supposed to be when it was about 80 degrees elevation. It was about 90 miles to the east of us when we did that. And we made a little movie. Let me show you the movie. This is really cool. So here it is. This is our focal plane. And here's Calypso marching through. We're seeing every flash, nice and strong. And these are 20 billionths of a second long. We couldn't have asked for a better testing. So we love it. And so we know our system works. And we're basically going to go forward with this if we can get this thing funded. But it turns out that it has yet another application. We hadn't really thought about this, but you do get flashes of light, which to us are interference, but to cosmic ray scientists are the thing they're really interested in. Flashes of light from high energy gamma rays or particles coming in as cosmic rays. And they're very short, just like the kinds of things we're looking for. And our set telescopes turn out to be just terrific for that. So we're already building 10 of these for an experiment that's funded from the European Union. And let me just show you what this idea is here. So this is the idea. This is sort of a cartoon, but a high energy particle comes in. It makes electron-positron pair, this thing, which is super relativistic. It makes a whole shower like this. And this is supposed to represent a flash of light. And this is an example of an experiment where you might have a lot of detectors to try to catch this. These detectors are non-directional. They just catch light. But our detectors image the sky. So we get much more information from it. And so what we plan to do is put an array of our telescopes out to look for these gamma rays. And the last thing I have to tell you is what Microsoft thinks this thing is. And it is, quote, a fire in the desert. Not exactly a fire, but it's the kind of flash of light that we're looking for. Anyway, that's what we're up to. I'm going to stop the share now and send it over to Vicky.
Just one question before we go to Vicky. What's the time scale for building that array in the desert?
It's how much money have you got? We can put these telescopes. They cost about 25 grand a piece, and it takes us a week to put one together or so. So
you mean each element in the
yeah,
array?
but look, this picture comes off a Japanese website. This is not our experiment. Our experiment would have those motorcycles with the mirror on the side spread out in the desert. And for initial plan, we're going to put 10 up either at Lick Observatory or Palomar. If that works out well, we're detecting gamma rays the way they like us to. The next plan is to put 100 of these. And for that, you can't fit those on Palomar or Lick. So for that, we'd probably go to some flat place. One possibility is the desert in Namibia. Another possibility is somewhere in the Southwest, like in Arizona or New Mexico. But that's a few steps away.
I'll say maybe near Caltech's radio observatories
Up
in the California desert. Yeah, a lot of flat.
Yeah, what is that called? The just east of
Owens Valley Radio Observatory.
Valley, yeah. That'd be good.
Yeah, plenty of real estate. A few jackrabbits. All right, Vicky, tell us what you're up to.
Okay, so I didn't know Frank as well personally as Paul did, but I certainly knew his contribution on astrobiology, and so I know him best through this that lovely phrasing, the second most famous equation in the world. So through the Drake equation, which is a formula and conceptual framework, which allows us to try and estimate the number of technologically advanced civilizations in the Milky Way galaxy. So the first 4 terms of this equation fall under the purview of astrophysics and the kind of astrobiology that I do, which looks for life's global impact on a planetary environment. And then the remaining 3 terms take us through the likelihood of the evolution and survival of technologically capable civilizations, which of course SETI focuses on. So my research focuses mostly on terms 3 and 4 of this equation, which are related to, knowing what fraction of planets are suitable for life's origins and the number of those planets on which life has in fact developed. So my research group, the Virtual Planetary Laboratory, is working to develop a theoretical framework. So, computer models and tests and things that we can do to support the development of NASA's next great space-based telescope, which is called the Habitable Worlds Observatory. We're very excited because this really is a very astrobiology-focused telescope. And so the HabWorlds mission will be able to search nearby planets for signs of habitability and life. And that's, obviously that's a huge step forward. Will take us maybe to 2040 or so. So it's, don't hold your breath, but it's amazing that we're on the path to developing this thing now. So my team is working on, how to identify the types of signs of life, which we call biosignatures, that we might want to look for, how the environment of a planet might fool us into thinking that life is there when in fact it isn't. And one of the most exciting bits of what we're about to do, we were just funded for another 5 years of research, and sort of the sort of centerpiece of that research will be the development of not just a virtual planet, but actually a virtual local solar neighborhood where we can populate it with planetary systems in our computer, and then try and understand, for planets in the habitable zone, we can play God and swap them out. We can put planets, every planet in the local solar neighborhood could have life, or every planet could have a false positive and trying to fool us, or every planet could be dead, or we could have some mix of all of these things. And so this model will allow us to then sort of sample the same way the Habitable Worlds Observatory might observe, because it's, it has a limited number of planets it can certainly observe. So we can look at the sort of constraints on that telescope and what it might be seeing, given different types of local solar neighborhoods, and then figure out, what is the chance that Habitable Worlds Observatory will in fact find life, based on a bunch of assumptions about how common life actually is. So we're very much looking forward to working with that. And so that will help, HWO or HabWorlds get a better estimate of the third and fourth terms in the Drake equation. And so that's what we're working on right now.
Vicky, I read somewhere, I'm not quite sure where, that there was an estimate that out of every 3 or 4 sun-like stars, there was a planet roughly the same size as the Earth in the habitable zone. In other words, the distance from that star where the temperatures could be commensurate with what you might expect to find here in California. Is that true? And if so, how does anybody know?
Well, I mean, I haven't actually heard that latest statistic, but the what we use for that. Okay, so there's 2 things. One, sure, it could be Earth size and it could be in the habitable zone. And yes, so we were able to get statistics from fantastic telescopes like the Kepler telescope and the TESS telescope, which tell us how often an Earth-sized planet shows up in that habitable zone region. And so that's where we're getting those statistics from. But I will say that that's great, because if a planet is in the habitable zone, it's more likely to be habitable. It's more likely to be able to support liquid water on its surface, but we don't know. We don't know. We have a theory. We think the habitable zone is a thing. We think that a planet in that region is potentially habitable, but we don't know. So what we need to do is we need to get a spectrum. We need to actually study the planet, determine whether or not it does in fact have an ocean on its surface. And so that's the next step for HabWorlds, and also potentially for the James Webb Space Telescope, is also potentially able to, in transmission spectroscopy, look at the composition of the atmosphere of planets and try and maybe get a handle on whether or not they're habitable, or at least if there's atmospheres there, that would be the next step. It would be like, okay, it's in the habitable zone. Does it have an atmosphere? Because we need an atmosphere, of course, to hold onto our ocean. So there's steps along the way that we can take, but certainly that statistic's very encouraging. But the proof is in the observation. We need to actually take observations of these planets to be able to tell.
Could you find oxygen in the atmosphere, for example?
Oxygen in the atmosphere of these? Well, with HabWorlds, yes. With JWST, no. So I've just published a paper saying how unbelievably hopeless it is to try and look for oxygen with JWST for a type of photosynthetic biosphere. If the planet has suffered a huge, massive ocean loss, it may have a dense enough oxygen atmosphere, like thousands of times the pressure of the surface of the Earth in oxygen, and JWST could see that. JWST can see ridiculously large amounts of O2, but the sort of 20% O2 that we have from our biosphere here, from our photosynthesis, that is not going to be possible with JWST.
Can I just jump in and say how amazing it is that you can do this? Because, naively, you might think here's a planet and here's this big atmosphere. It's not that way at all. If the Earth were a tennis ball, then the atmosphere is about the thickness of a piece of paper. You can almost reach up to outer space. Outer space is what, 60 or 80 miles up. The Earth is 8,000 miles in diameter. So you have this thin little sliver of atmosphere, and you're going to see light being transmitted through that, and you're going to look for spectral absorptions or re-emissions while this thing passes in front of this huge disk of an exostar. Amazing that you can do this at all.
Yeah, I like to say it's like the skin of an onion. That's what we're trying to, you slice an onion with the skin on, that's what we're trying to look for. And I love to not discourage, but, maybe amaze people by showing them, the shots seen from the space shuttle of, that thin blue line. Even you can see it behind me right now, that thin blue line, right? That is the atmosphere in transmission. And so, this region up here, if you can, I don't know if you can see my cursor, you probably can't. But yeah, I mean, that's what we're looking for on, that difference compared to the actual radius of the Earth. So it's going to be a very challenging observation, but we're actually starting to try and do that with JWST. And in fact, we do have not we, but other members of the community have observations of TRAPPIST-1e that are currently being approved in cycle 3, which have the potential to actually see whether or not there's an atmosphere there, and possibly even look for molecules in the atmosphere of TRAPPIST-1e, which is an Earth-sized planet in the habitable zone around a very nearby M-dwarf star.
Amazing. Amazing. Especially when you think that, 20, 30 years ago, we didn't know about any planets around other stars, right? I mean, that's relatively new, exoplanets, I think. Okay, we're going to get to more of this program. I think that we switch over here to the auditorium where we'll see a video about Franck and some opening remarks from Moiya McTier and so forth. I think Steve Bordeaux has to throw a big knife switch somewhere to do this. I don't know if Steve can even hear me and whether he even has access to the knife switch. But if you do, Steve, why don't you do that now? Because it is indeed 7 o'clock. I'm betting it won't happen. I lose the bet.
It's not 7, it's 10 o'clock.
You're in the wrong part of the world there. You can watch this interesting graphic. Well, we may have a few moments here. Maybe I'll just tell one of my many anecdotes about Franck Drake, whom I've known since, I guess I first met Franck in 1972. He came to the National Radio Astronomy Observatory down in Charlottesville, Virginia, where I had a postdoc position. Anyhow, my impression was, gosh, this is a really smart guy. But the larger impression was that this is really a really nice guy. So, and that never changed. I used to refer to Franck among friends as the world's last nice guy. I hope he wasn't. It doesn't augur well for our own society, but he was that.
Franck was very, very special.
He was. And, something that I noticed about him was that he was incredibly patient. His office was 20 feet down the hall from mine. And people would go into his office. And of course, Franck is doing something, right? He's busy like everybody else. But he would always stop. And he would turn toward whoever had walked into his office and ask them, could he help them? That kind of thing. And I asked him about that. I said, Franck, you have this patience. Did you get that from your family? I mean, is it, the consequence of having kids and so forth? He said, no. He said it was the consequence of having students. Is that true, Paul?
Well, I've known some professors who snarl at their students, so I think Franck was Franck, and whether students were involved or not, that's the kind of person he was.
Yeah. I went on numerous eclipse trips with Franck, some of them to Africa and places like that. We were somewhere in Africa, and the trees were filled with these other simians, not like Andrew, but I mean, other simians, jumping around and so forth and so on. And if you looked at them kind of casually, you'd think, their behavior is not so different from ours. And Frank was sitting next to me and he said, yeah, he says, you look at them and you think, man, they really are, almost humans. He said, but they really have a long way to go. Mm. And he thought maybe that wasn't so encouraging. But then he followed that up by saying, well, when you think of of deep time and how long deep time really is, he was more optimistic that you could go from simians to us in a relatively short order.
Well, if the age of the Earth is mapped onto one day, then those things were wandering around about 4 or 5 tenths of a second ago.
Yeah.
It's 50,000 years per second. That was a few seconds ago. But no, we've moved quickly. And that was even before the iPad and and artificial intelligence and flying jetpacks. I'm
still waiting for those, along with my flying car. But well, let me ask you, as long as you're talking about this, Paul, what about, how quickly will artificial intelligence, generalized artificial intelligence, how quickly will that move, right? Any idea? I mean, assuming we can develop it.
Well, quicker than our brains change. Martin Rees, of the UK, the Astronomer Royal, who's actually part of the Breakthrough project, when asked, when we first established contact with extraterrestrial intelligence, what is it likely to be? Argues it's likely to be silicon or whatever the processing technology is of the time, not biological, because
actually I said that at a meeting with him.
Maybe he learned it from you, but yeah. I guess the argument is
he learned it from a machine.
The rate at which machines are getting smarter is not slowing down. In fact, it's probably speeding up. At the rate at which we're getting smarter, we've basically stopped. I mean, our brains are limited to what they are, and so if you're going to communicate with really, really advanced creatures, they're probably not going to be made out of biological material.
Yeah.
I mean, AI has just been stunning in what it's done. I mean, I guess the people in AI have known this for 10 or 20 years, what's coming. But the fact is, when they dropped ChatGPT on the world, everybody woke up to the fact this thing isn't half bad. And it's getting pretty amazing, just in the span of 3 or 6 months. It seems astonishing.
Yeah. So are we the last biological intelligence to control the planet?
Well, it's not going to be those other simians, and it's not going to be dinosaurs.
Okay, where are we? The screen is changing.
Yeah, something's happening.
We're seating at the event right now and just waiting for everybody to get settled. So you guys can go ahead and keep chatting.
All right.
Yeah.
Paul, you mentioned, you really described optical SETI, where instead of looking for radio waves, you look for flashing laser lights in the sky or something similar. People used to argue about which was more likely to result in success. Do you have any thoughts on that these days?
Well, I went down the same rabbit holes that all of us did, which is, in 1959, 1960, we had Project Ozma, we had Okoń and Morrison, and we had really good radio technology already. And lasers weren't invented till 1961, so we didn't have anything very significant in terms of making strong optical radiation. So when you're talking about communication over long distances and people are hams and so on, they think radio waves. And so that was the doctrine. That's what everybody's trying to do. But I woke up to this thing about optical because of Charlie Townes, who wrote some very nice papers, and a very good one in 1983. Suddenly there were lasers which could project prodigious amounts of power and in much, much sharper beams because of the short wavelength than radio. And so the disadvantage of optical, which is that the photons cost more, is more than overcome by the directionality of a beam you can make. And also by the way you can convey much more information at these higher frequencies, higher carrier frequencies. And so you can do a calculation. We've all done the same calculation. For radio, we say how much signal will be received at 1,000 light years. We use these dishes. For optical, you can say how many photons will be received in a nanosecond pulse. We're doing some kind of pulse modulation. And the answer is, if you use the Keck telescope here, and you have a Keck-sized 10-meter telescope on an exoplanet 1,000 light years away, and we make a flash of light using the telescope to aim at their telescope, you get about 1,000 photons for each pulse using the best lasers we have on Earth now, which must be considered primitive for the same argument we've been making about the growth of technology. So right now, we can make flashes of light which are well received at 1,000 light years, but the only thing we need is these two telescopes pointing at each other, and which far outshine the brightness of the star, which, even if we assume that they can't distinguish them because they have crappy telescopes, we will give them a strong signal. So I've kind of sort of come around to the idea optical's pretty good, except for weather. You know, you have to do it when the sky's clear, you have to do it at night. That's sort of a kludge. But I see you staring, Seth. What are you doing? Are you reading?
No, I'm just reading Vicky's commentary here to somebody who asked a question. No, I wasn't looking for flashing lasers. Just
All right, everyone, we're ready to go to the ceremony.
This array of antennas, situated in the Cascade Mountains of Northern California, is not tracing the interstellar gas of our galaxy. It's not imaging objects like pulsars, quasars, or the neighborhoods of black holes. It's searching for evidence of intelligent extraterrestrials, aliens. This endeavor is known as SETI, the Search for Extraterrestrial Intelligence. It is a daring experiment that could forever alter humanity's view of itself. An experiment to use modern technology to find other galactic inhabitants was first attempted by a soft-spoken astronomer named Frank Drake. Born in Chicago at the start of the Great Depression, Drake was interested in chemistry and electronics. He enrolled at Cornell University and was part of a Navy officer training program. After graduating, Drake was put in charge of electronics aboard a Navy cruiser, the USS Albany. In 1955, he entered Harvard as a radio astronomy grad student. After receiving his degree, the young Frank Drake joined the newly minted National Radio Astronomy Observatory in the soft hills of West Virginia. The observatory had just purchased an off-the-shelf radio antenna sporting an 85-foot dish, and Drake, the new guy in town, was encouraged to think of experiments befitting this instrument. What followed was a 2-month observing program he christened Project Ozma after the fictional Princess Oz in Frank Baum's book. In an experiment that discomfited some astronomers, Drake used the antenna to look for radio signals coming from the directions of 2 nearby stars, places that could conceivably house planets with intelligent beings. He wasn't studying natural processes, but looking for emissions launched into space by an extraterrestrial society. He didn't find any alien signals, but Project Ozma had generated a tidal wave of interest. A year later, Drake was encouraged by the National Academy of Sciences to convene a small meeting of a dozen scientists to weigh the odds that we could find aliens by eavesdropping on radio transmissions. The meeting was held in the fall of 1961 at the observatory where Drake had done Project Ozma. As agenda for the meeting, he wrote a simple equation on a blackboard that would estimate the number of on-the-air societies that exist in our galaxy. This agenda, now known as the Drake equation, has been called the second most famous equation in science. Thus began the modern era of SETI. Drake had planted a seed that has sprouted into several signal searches in progress today. These efforts are constrained not by a lack of technical expertise or astronomical knowledge, but by a shortage of funding. SETI is run on monies donated by a handful of interested individuals.
We will need to search through literally at least millions of stars to give us a good chance of finding a signal from another civilization.
SETI experiments have not yet found proof of extraterrestrials, but a small number of scientists are continuing the search with new observation programs and the development of new receiving equipment. By 2035, these experiments will have reconnoitered about 1 million planetary systems, an impressive sample. So it's conceivable that Drake's audacious experiment will soon pay off, that we will learn that humans are not the only intelligent species in the cosmos, that we share the universe with others.
Good evening, everyone. Hello. Ah, oh yes, you can clap for me, sure. Good evening, everyone. Welcome to the 2024 Drake Awards, which is really what deserves the applause, so you can clap now. Thank you. I'm Dr. Moiya McTier, and I am so honored to be your host this evening for the second year in a row, so I must have done something right last year. But I have an extra responsibility this year. I am here to make sure that all of the awardees get up on stage on time so that we do not interrupt your dinner. That's a promise that I'm going to make to you. I know I'm a stranger to most of you, so here's a little bit about me. I am a folklorist. I'm a mythologist and an author who also happens to have a PhD in astrophysics. I've studied planets and stars and galaxies and, importantly, stories. Being a folklorist has taught me that humans tell stories about the things that we think are most important. And for thousands of years, humans have been telling stories about space. Myths tell us what cultures from around the world thought the universe was like. They tell us how they thought the universe formed and what our place in it was. And then we started to wonder if we were alone. We actually started to think about extraterrestrial life. And so for the last several hundred years, some would say over 1,000, we've been telling stories that explore the idea of other life existing out there. Thanks to science fiction, we have stories about Martians, about little gray men, about Vulcans who want us to live long and prosper. And in a shorter but no less impressive legacy, the SETI Institute has been around for 40 years. And in those 40 years, they've been using science to try and tease out the facts from those fictions, all while inspiring the next generations of both scientists and sci-fi writers. And look how far SETI research has come in the last few decades. The video told us about Project Ozma. In 1960, Frank Drake's Project Ozma studied radio waves from just 2 stars looking for signs of life. And now there's a SETI instrument that works with the Very Large Array in New Mexico that is going to do an all-sky search for technological markers of an alien civilization. How cool is that? That's amazing progress. And it was only made possible because the SETI Institute persevered in the face of NASA funding shortages and public stigma. And I'm really excited that those obstacles are starting to get smaller now. But that is thanks to the Institute's incredible scientific contributions, not just contributions made to the search for extraterrestrial intelligence, but in fields of astrobiology, planetary science, climate research, and instrumentation. That knowledge is priceless, as are the technological advances that have been made possible by the research here. But in my humble opinion, the Institute's biggest cultural contribution has been the way it inspires awe and wonder. So much of the science that gets shared with the public is about what we've already learned. It creates the illusion that being a scientist is about knowing things, when in reality, being a scientist is more like empathizing with Jon Snow and admitting that we know nothing. I expected more Game of Thrones fans in the audience. But let me see. SETI has learned a lot. But one of my favorite things about SETI is that it's more upfront than most other institutions about the fact that they don't know what they're going to find. And that's a really important message for the public to hear. They need to know that it's okay to embark on a curiosity journey, even when we don't know what the destination is, and that it's okay not to have all the answers all the time. But most importantly, they and we need to know that in a universe as big as ours, the possibilities truly are endless. And I'll be the first to thank the SETI Institute and its researchers for spreading that message. So thank you all. And tonight you're going to get to meet some of those researchers and hear about their work. So to help me kick off the ceremony, I'd like to invite Bill Diamond, the CEO of the SETI Institute, to the stage. Give a big round of applause for Bill. Thank you.
Thank you, Moiya.
Oh, yeah.
There's a reason Moiya's here 2 years in a row, because she's awesome. That's why she's here 2 years.
Thank you.
So welcome, everybody, and thank you very much for coming. What's very cool is to see so much energy in this group, so much so that you all missed the 3-minute video that took us years to produce. It's the entire story of the SETI Institute told in 3 minutes, It had an opportunity to meet Frank Drake. You heard from him directly. You all missed it because you were having such a good time. But that's the end of our show, so thank you so much. No, anyway, it's so wonderful that you're all here. And we're so grateful to have all of this support and all this interest in our programs. And I want to thank, among others, many members of the Board of Trustees of the SETI Institute who are here tonight sponsoring tables. And if the members of the board could just raise their hand, I'm not going to call you out individually. Their primary responsibility is keeping me honest, which is a tall order, but they do an excellent job. And one of them in particular I want to call out because we believe, at least we have a bet that this individual may have the award for traveling the farthest to get here. He came from Hong Kong via Berlin, and that's Fritz Demopoulos. Where's Fritz? So if anybody out traveled Fritz, please come and tell us. You do get a special prize. I'd also like to call out members of the Council of Advisors of the SETI Institute who are volunteer donors and supporters of the Institute who also help us with special projects and programs. And if you're in the audience also, please raise your hand because we're so appreciative of you. We also have two members of our Science Advisory Board. Our Science Advisory Board is an extraordinary group of researchers and scholars from all over the world, including among them the Vatican astronomer, Brother Guy Consolmagno. But we have Mike Garrett, who heads the Jodrell Bank Observatory and is a radio astronomer at the University of Manchester. Mike is here. And the newest member of our Science Advisory Board is Dr. Minnie Wadhwa from the Arizona State University. And she's the head of Earth and Planetary and Earth Sciences at ASU. So where's Minnie? There she is. So welcome. And now I would like to call out the most significant and wonderful guest that we have joining us tonight. And that is none other than the founder of the SETI Institute and the inspiration and the reason we're all here tonight, and that's Dr. Jill Tarter. We're so honored to have Jill with us tonight. And Jill founded this institute 40 years ago this year. And so if you have a good time at this party, we're going to have an even bigger party on November 20th of this year, which is the actual day of the 40th anniversary when the stamp went on the paperwork establishing the SETI Institute as a legal entity and 501c3 nonprofit, 1984. So don't miss that event. And Jill not only was the founder and inspirational leader of the SETI Institute and still is, but Jill was married to a very special gentleman who we sadly lost this year, but who over a 90-year life made so many extraordinary contributions to the fields of astronomy and signal processing and electronics. And that is her husband, Jack Welch. And so I'd like to tell you a little bit about Jack. So Jack got his BA in physics in 1955 and his PhD at UC Berkeley in engineering science in 1960. And he was a UCB professor in electrical engineering and computer science in the astronomy department, also in the graduate school. He led research on millimeter interferometry and frequency independent feeds and receivers. And he was the co-discoverer with Charles Townes, who's a Nobel laureate and another recipient of the Drake Award, the second recipient of the Drake Award after Frank Drake himself. They discovered together interstellar ammonia and interstellar water. And he was the director of the UC Berkeley Radio Astronomy Laboratory from 1971 to 1996. Jack was a member of the SETI Institute Board of Directors from its founding in 1984 through 2014. And he held the UC Berkeley, Marilyn and Watson Alberts Chair for SETI from 1998 to 2011. And he also designed and developed the second generation Allen telescope feeds, the feeds that we are still building and installing on the Allen telescope array as we speak, that have really pumped new life and new incredible capabilities into that instrument. And he was working on and planning observational projects right up until he passed away earlier this year. I met Jack back in 2017 at the Allen Telescope Array. I should say I met Jack's lower half, because the upper half of his body was actually inside one of the telescopes. So my first greeting with Jack was a pair of legs on a ladder underneath one of the telescopes doing some work. But it was such an honor and a privilege to meet him, and certainly the thrill of a lifetime for myself to be able to be around people like Jill, like Frank, and indeed all the scientists, educators, scholars, board members, and other family members of the SETI Institute. So before I turn it back over to Moiya, I will admit the fact that some people are looking and saying, why is this guy dressed in black from head to toe? Well, I think the reason should be obvious, that if you engage and meet someone from the SETI Institute, your expectation is they should be the men in black. So there we go. And then the last thing I'd like to do is, because my wife couldn't join us tonight, is I'd like to take a picture, because she's going to ask me, like, did anybody show up for your party? So I want to be able to say, yes, they did. So look this way and everybody say cheers.
Yeah.
There we go. Yeah, that's what a clever idea. See, it takes an engineer.
Yeah. Yay. Great
All
job.
right, Moiya, it's back to you.
It's back to me. Thanks, Bill. And thank you all for joining. Tonight is a celebration of science and curiosity and the people who wield it to do that great science. And tonight's celebration is made possible by an amazing group of sponsors. And I am going to name you individually. So please give a wave, give a shout when I call you, so that we all know who to thank for making this event happen. So our table sponsors tonight include Amaresh Kolapari, John and Carol Gianandrea, Mohanjit Fawley, Eric and Hillary Charlton, Dan Langford, Manan Latif, and the SETI Institute leadership team. Let's give them all a round of applause. Thank you so much for sponsoring the tables. And we also have sponsors of the awards segments tonight. So the awards have been sponsored by Avery Wang and Katya Rolt Wang. Thank you. Yep. Also, Helmi El-Tuki and Breakthrough Listen. So thank you all sponsors so much. I'm really excited for you to meet the awardees for all of the awards tonight, but I'm also excited to eat. So we have about a 20-minute break for you to eat dinner, and then we'll get back to the rest of the awards ceremony and hand out some awards. So enjoy.
All right, everybody, I've got a couple videos for you to watch. So just sit back and relax.
Hi, I am Pascal Lee. I'm a planetary scientist at the SETI Institute, and I'm very happy to welcome everybody to the Drake Awards this year. I work mostly on the story of ice and water in the solar system, but in particular on the moon and Mars. Life, of course, is really dependent on the presence and availability of water, especially liquid water. And I remember when I first got hired at the SETI Institute, Frank Drake was part of the interviewing board. And at the end of my presentation, which was about studying Mars and the history of water on Mars, he turned to his assistant and said, let's sign him up under N sub E. So apparently for a while there, scientists at the SETI Institute were hired to address different terms of the Drake equation. And the N sub E term is the one that determines a number of environments within a planetary system that are suitable for life. And so studying water on Mars fell in that category. So I guess that's my one connection to the Drake equation. In more recent times, I've also been arguing that the number of advanced civilizations in our own galaxy might actually be lower than we would hope, but that at the same time, even with a low number per galaxy, there are hundreds of billions of galaxies out there. And so we are still in very good company in the cosmos, but should really be listening not just locally, but searching for technosignatures from other galaxies as well, if we can. To me, the Drake Award is a big deal. I really want to congratulate those who are getting it this year, especially Andrew Siemion, who's getting the Drake Award, but also my colleague Franck Marchis, who's getting the Carl Sagan Center Directors Award. Big congrats to both of you, and also to the SETI Forward awardees this year. No small feat to get a Drake Award, and I'm very happy to see that you're having them. I have been excited by every planetary mission that has gone out into the solar system since we've been sending missions into space. I remember really reading very excitedly as a kid the reports from the Viking mission, the first mission that landed at the surface of Mars, returned pictures from the surface, and really turned a planet into a landscape. So that to me remains a very vivid and memorable experience. And then since then, every landing on Mars takes us to a very different part of this incredible planet. Recently, I was lucky to be able to announce the discovery of the remains of a glacier near Mars's equator. Work that I did with my graduate student colleague Surab Shubham at the University of Maryland. But just this year, we both announced as well the discovery of a giant volcano on Mars. If you can believe that anything that big could still be hiding in plain sight and not have been detected sooner. But sure enough, we were looking for a volcano in just the right place to explain why we were seeing some volcanic deposits associated with our glacier. And sure enough, as we zoomed out enough, we started seeing this monumental volcano, very eroded, so hard to recognize at first glance. But we started seeing the remains of this giant volcano within which our glacier was located. Mars still has many secrets, probably, that are remaining to be found. And I think Carl Sagan maybe said it the best. I was lucky to once be his last TA at Cornell, but Carl said, somewhere something incredible is waiting to be found. And so I think that really holds true for Mars and many other places in our solar system and beyond. So if you're attending the Drake Awards this evening, know that everybody, and especially the scientists at the SETI Institute, are very grateful for your support, your interest in what we do. And we never have enough support. So in case you are so inclined, thank you for continuing to support our work.
So I'm Uma Gorti. I'm a research scientist at the SETI Institute, and I work on how stars and planets form, and more specifically on these disks that surround them, and how they lead to the formation, the birth of stars and planets. Most of my work is actually theoretical, so it's computational in nature mostly. And I work with a lot of observers and sort of try to interpret what we see by various telescopes. My background is physics, and I really liked in astrophysics, and particularly the field of star and planet formation, how there were all these processes and different kinds of physics, like there's magnetic fields, there's turbulence, there's fluid flows, there's radiation, of course, gravity, and in many different things that come together to produce these stars and planets. And because there are all these different processes working, it's not very intuitive. Like you can't really, because they kind of interact in very complex ways, and that makes it, sort of a very interesting puzzle to solve. And also because you're solving one problem, and you get to sort of work on all these different sub areas, if you will, and that's kind of what got me into it. So it has to do with actually the very first two terms of the Drake equation. So that is the rate at which stars form in the galaxy. So that is the star formation part of it. So because that's the very first thing, what is the rate at which how material in the molecular clouds in the galaxy. So this is basically material in between stars, which is mostly hydrogen, how it collapses and forms stars. And it turns out it's not a very efficient process. It just happens at like a few percent efficiency or something like that. And so this is the very first term that we need to understand, so how do stars form? And then the second step, which is like once you form the stars, then which of those form planets. And so planet formation is tightly linked to star formation because they happen sort of simultaneously. And so that is the next step in this Drake equation. So my work has to do with the very first two terms in the equation. We currently actually do not understand much about stars and planet formation. And in fact, what's happened is that in recent years, we've collected more data with telescopes like Kepler and TESS and, radial velocity surveys. And we kind of found that, what we thought earlier, which was that our solar system was kind of a typical, planetary system we will be looking for, is totally not true. So the exoplanetary systems out there seem to be completely different from our planetary system. So we really have, we had built these theories of star and planet formation, trying to explain how our solar system came to be. But now that has all been upended. So I think that there's plenty that's left to be discovered. And I'm quite sure that as we discover more phenomena, have new facilities, it is only going to get more complicated because we like almost most of the time we find things we don't expect to see. So like when we're looking at disks, for example, we found that planet formation seems to happen much earlier than people thought before. Like this is when when the disk environment is completely enshrouded in material, whereas before this it was thought that planets form much later in the process of the whole evolutionary sequence. And theoretically, the problem is quite challenging, and because of the same reasons I mentioned before, there are all these different things going on, and there are all these complex levels of interaction. So I think that, sort of as maybe as we get computational prowess increases, we can get towards simulating these things much more. But there's actually really quite a lot of work to be done, and I don't know if we will have all the answers to the questions we have even now in 40 years. So, yeah. It's an honor to get a recognition like that, I think, and really proud of it. And I think, yeah, I mean, it's nice to be recognized for the work that you do and to be singled out, especially in the SETI Institute. I mean, there are so many people doing such fabulous work, and it's indeed a great honor to be recognized like that. Yes, so my congratulations to Andrew, very well deserved, and look forward to the event, and also congratulations to Frank as well. Yeah.
you know that?
Seth, if you want to talk to the audience for a few more moments, we're still waiting for them to wrap up dinner.
Oh, okay. Is there an audience? Is anybody listening to the sound of my voice? Well, if so, my apologies. But I've been told by one of the organizers, Beth Johnson, to speak to you just for, you know, I don't know, maybe 2 or 3 hours here. I'd like to talk to you about the effects of inverse confidence scattering on the forbidden line transitions of yttrium in the atmospheres of peculiar A-type stars. Our recent survey suggested that this is the subject that most of you are interested in. Actually, what I will tell you is explain something that people occasionally ask me about, because when the media, when they talk to me, ask, well, when are you guys going to find ET? Because you haven't so far. I usually say within 20 years. I've been saying that for probably 30 years, but you know, and so why do I say within 20 years? Is it just wishful thinking? Well, it could be just wishful thinking, but I'm not so sure of that. Because if you just look at the number of channels that our receivers have, in other words, how much of the radio dial are we monitoring, looking for signals, radio signals from space? And you look at that, and you know, it used to be a few, and then it was 100, and then it was more. Now it's, you know, tens of thousands, whatever it is. But that number goes up exponentially, a heavily overworked word in the country today, but it goes up exponentially. So you can easily predict how long it will be before we've looked at 1 million stars systems. And that's on the order of 20 years.
Sorry to interrupt your eating. You can continue eating if you would like, but I am going to keep talking because we are about to hand out some awards. Are you ready to hear some awards? Great, great. Who here has watched Cosmos with Carl Sagan? By a show of hands. Okay, my hand unfortunately has to remain down because I was born too late and grew up without TV to watch Cosmos, but I have always been inspired by Carl Sagan. I really admire him for the way that he could talk about science like a poet. I think that's one of the most amazing skills. I even named my podcast after his iconic pale blue dot quote, because no one knew how to connect with an audience like Carl Sagan. And the most incredible thing about him is that he was as skilled a scientist and researcher as he was a communicator. And so the Carl Sagan Center is the research arm of the SETI Institute, very appropriately. With over 100 principal investigators organized under 6 different research areas, the Carl Sagan Center for Research does a lot of amazing work. And tonight, the Institute presents the recipient of the 2024 Carl Sagan Center Directors Award. And this is thanks to the sponsor of this award segment, Avery Wang and Katya Rolt Wang. So thank you. And to introduce the recipient of this year's Carl Sagan Center Award, I would like to invite to the stage Natalie Cabral. Where are you, Natalie? Hello. Natalie is the director of the Carl Sagan Center for Research. So thank you, Natalie. You're here.
All right, good evening, everybody. I'm Natalie Cabral, and I'm the director of the Carl Sagan Center for Research at the SETI Institute. And each year we honor one of our scientists for their accomplishment, but it's more than just for science. This award also celebrates their excellence in education, outreach, and service. And speaking of going the extra mile, Dr. Franck Marchis, who is honored tonight, is quite the frequent flyer. You'll soon understand why Frank is standing, or soon standing, here tonight. But before, let's just say that what strikes me most about him is his passion and the contagious joy for what he does. Franck is a planetary astronomer with a PhD from the University of Toulouse in France. He joined the SETI Institute in 2007 and was part of the first Science Council. Franck is actively involved in startups that promote science, outreach, and astronomy. In 2017, he co-founded and joined Unistellar as its chief scientific officer, and VR2 Planet as a scientific advisor. He is an active member of numerous scientific committees and was honored in 2023 as a fellow of the California Academy of Sciences. Franck develops the next generation of adapted optics for large telescopes. He is the collaboration manager on the Gemini Planet Imager Exoplanet Survey, which studies Jupiter-like exoplanet at the Gemini South Telescope. His research focuses on asteroids with moons in recognition of his discovery for the first triple asteroid system in 2007. Asteroid 6639 was named Marchis. In collaboration with Unistellars and the SETI Institute, Franck created a global community of over 2,000 citizen astronomers who use unistellar telescopes to gather data on astronomical phenomena. This initiative has led to peer-reviewed publications in planetary science, and their observation of the DART impact and Dimorphos contributed a paper in Nature. Franck played a key role in the SETI Institute's participation in the International Art Project, A Sign in Space, which involved sending an encoded message from ESA's ExoMars back to Earth. He hosted a 2-hour live stream event interviewing artists, engineers, and scientists while answering audiences' questions in real time, showcasing his ability to bridge art and science. He was also instrumental in organizing the SETI Institute monthly public lecture series and the SETI Lab weekly social media live stream, which explores progress in space science and spark discussions. Recently, he led successful outreach campaigns for the annular and solar eclipses, engaging people worldwide. Franck is an active ambassador for the SETI Institute, forging relationships in Saudi Arabia, Dubai, the Maldives, and throughout Europe. Franck, one of my dreams would be to see people around the world as happy as you are, going through life with passion and commitment to science, education, outreach, and service to that fundamental part of the SETI Institute's mission, which is to share knowledge with the world. It is therefore my honor and privilege tonight to name you the 2024 CSC Directors Award recipient on behalf of your colleagues, the Science Council, and the leadership of the SETI Institute. Congratulations, Franck. So I have to say too that you know that the Olympic Games are in France this year. He's the first medalist. Wherever it is, over there.
Thank you very much. Wow. I'm a scientist. I'm not very good at getting honors like that and make speeches and so on. So I prepare a few slides because I know we cannot have a conversation without slides, right? So first of all, thank you very much to the Science Council for choosing me as a recipient for the 2024 Carl Sagan Award. I think it's a very special year for the SETI Institute, so I'm double honored the fact that I'm getting it this year because it's a very interesting year for us, and also because there is the word Carl Sagan in this award, and somehow Carl Sagan always influenced me. As a kid, I watched Cosmos, read his books, and I always dream about one day working in an institute that searched for extraterrestrial life. And here I am getting an award on his name. So thank you very much again. So I'm gonna basically say a bit about why I've been working at the SETI Institute for 16 years and why I think it's one of the most amazing places to work as a researcher. This is what I chose as a strength of the Institute. There is way more, of course. I'm not gonna talk about everything. But one thing really that I think is very unique in our Institute is the exploration part. When I see my colleague traveling around the world, going to Antarctica, Chile, Arctica, diving, looking for life in extreme environment, I think it's truly inspiring, and there is a story to tell here. I love the fact that we started at the SETI Institute this idea of community science. I mean, there is SETI at home, there is camps, there is a lot of projects where we involve the public in science, creating the first generation of citizen scientists. We are also an institute which focuses on innovation. Think about the creation of FDL that brought AI to space. I mean, we are the first institute who have done that. And we are now kind of reference for most people who study AI and use AI for space exploration. We have an amazing artist in residence program. We mentioned the Sign in Space, which basically attract the attention of millions of people. We had 2 million downloads of the data in 1 week when we posted them on the network. We're also a team of instrumentalists. I love talking to my colleagues about the new instrument they're designing, hearing about the story when they test them in the bottom of lakes or ocean, when they go to observatories and put together those cameras that will one day image a potential Earth-like exoplanet. And finally, I love the education and outreach. A clear example we have at the SETI Institute of the success of our program is when people know about us by name. Even when you go to the Maldives, they know about the SETI Institute. They have heard about our SETI Live. They have heard about our social media. When you go to conferences, you meet these young people, young professors who remember the first time they did science. It was at the SETI Institute in the RAU program. So thank you for all of you for doing this. The people is really the last part of the puzzle that I wanted to mention. The people are the researcher, but also the admin, the IT, the HR, who really tried to make sure that we follow some rules and regulation. Thank you. And also our grant manager, who always keep us focused on writing those grants that will fund our research. So all of this, the reason I get this award is not only for my research, is because of the contribution of all of you, the strengths that you bring to my research. And the creation of Unistellar is basically the heritage of the SETI Institute. When you look at Unistellar, the network, the goal, the instruments, the outreach, and so on, we basically took what have been done at the SETI Institute for 15 years, and we put it in this private company. So thank you very much. I know I have 5 minutes only. I have no idea how long I've been talking, but I want to give 2 examples here. Outreach and education. 15,000 people watched live the eclipse in April 8th of this year. We had stations located along the path of the eclipse, and some people experienced for the first time a total eclipse, and so our reaction. I went to France last week, and I met people who watched the program and mentioned to me how cool it was to see scientists, researchers, board members, students, and so on, who experience and talk about the eclipse. This is great for us because our name is now spread around the world thanks to this astronomical event. And I think we should do more of those in the future. I want to talk about 2 scientific results that I think are iconic in our research. One of them on the right is the discovery of the true exoplanet, Jupiter-like exoplanet. What we meant by that is a planet like Jupiter orbiting a star called 51 Eridani, 100 light years away from us. And the tiny dot you see here moving at the bottom at around 6 p.m. is basically the planet. It's an image of a planet taken with the Gemini Planet Imager, an instrument which was built over for 10 years to detect and characterize, search, detect, and characterize exoplanets like Jupiter. We published this in 2015, and that was the beginning of an era where now humanity can see exoplanet, and in the future, we hope to be able to see Earth-like exoplanet, so hopefully detect life on one of those worlds. On the left, you see another observation, take this time with a tiny telescope, the Unistellar telescope from Réunion Island. What you see here is the impact of a spacecraft, the DART spacecraft, on Didymos, Dimorphos, the moon of Didymos, and near-Earth asteroid. You can see the puff of the explosion shortly after the impact. This is an important video, an image, because from this observation, we basically confirm that humanity is not capable of deflecting an asteroid that could potentially impact our planet. This was done in 2022 and published in 2023 by the members of my group. So someone asked me to talk about the future, how I see the future of my research at the SETI Institute. So I asked the intelligence I'm talking the most at the moment, it's called ChatGPT. And I asked ChatGPT, please draw me an image of what will be the future of the SETI Institute. So on the left, you have what ChatGPT see. Andrew is going to be super happy about that, because what ChatGPT believes is that we are going to build on Mars, not on Earth, on Mars, an array of antennas, and we will be basically looking at the data through these kind of holograms and wearing spacesuit. Natalie will be super happy about this because she loves spacesuit as well. And that's the way we're going to be looking for aliens. So I told ChatGPT, maybe you should change a little bit to broaden your vision. What about we include some astronomy and so on? And this is more my vision, which is we will continue to expand the unistellar network. We will have the laser SETI network as well, CAMS and other network, because the goal here is to be able to observe the sky 24/7 in the idea of, with the goal of detecting a signal coming from an extraterrestrial civilization, but also be able to characterize and understand the universe, like finding, for instance, an Earth-like exoplanet. And that's the future I hope we're going to have all together. Thank you very much.
Thank you, Franck, and congratulations. I'll say from one science communicator to another, it's really nice and appropriate to see an award named for Carl Sagan go to someone who cares so much about public outreach. So congratulations again. The next award this evening looks to the future of SETI research, and it's about the SETI Forward program. This launched 5 years ago at the SETI Institute, and it's due in large part thanks to Lou Levy and Dane Glasgow and other supporters who started the SETI Forward Endowment Fund. They did that with the express purpose of encouraging outstanding undergraduates to pursue careers in the search for life beyond Earth. It's what we all want, right? In the 5 years that the program has been around, 13 SETI Forward Awards have been granted. And earlier this year, they had a reunion where 9 of the 13 got together and talked about how the award has impacted their careers, all in a very positive way. In just a few moments, you're going to get to meet the next cohort of SETI Forward awardees. But first, I'd like to invite the founder of the SETI Forward program, Lou Levy, up to the stage.
Hello, everyone. First off, it is my pleasure to introduce Dr. Steve Croft and Helmi Eltouki, who will both join me in presenting the SETI Forward Awards this year. Helmi Eltouki is a SETI Institute trustee and CEO of Guardant Health. Helmi generously sponsored tonight's SETI Forward Award segment. Dr. Steve Croft is an astrophysicist with Breakthrough Listen at UC Berkeley and an adjunct senior astronomer at the SETI Institute. Steve has been instrumental in building up the collaboration between the SETI Institute, Breakthrough Listen, and Berkeley SETI Research Center. Steve is also a member of the SETI Forward Selection Committee. It's been 5 years. It's amazing. Despite what my memory says, it really was over 5 years ago. I was sitting at SETI Institute discussing a 5-year plan for SETI Forward, and here we are. We wanted to expand the award outreach to be truly international, and to have multiple award recipients representing a diversity of gender, geography, and disciplines. As witnessed by tonight's recipients, these goals were achieved. In April, we had a 5-year celebration which brought together 9 of the 13 previous recipients. It was great to hear how so many of the award recipients are continuing their work in the search for life. As SETI Forward continues, we want to work on building up the community and collaboration. At the celebration, we witnessed the synergy across the years. We hope to see the SETI Forward community continue to grow and find new ways to expand their knowledge of life. Please meet our presenters, current award recipients, and potential future Drake Award recipients.
Thanks, Lou. Our first recipient of the SETI Forward Award this evening, Dana Yaptangco, just a few days ago received her undergraduate degree in astrophysics from the University of Florida. And in the fall, she will be starting a PhD in astronomy at Imperial College London. Dana was a participant in the REU program that I direct at UC Berkeley, but as we do with these programs, we're very collaborative, and her immediate mentors were Doctors Anne-Marie Cody and Daniel Giles at the SETI Institute. And Dana's project involved the simulation of megastructures around stars, so the idea that we might be able to detect signs of engineering through the dips in the light of stars, and Dana was able to show the detectability through these simulations and predict how they might be picked up by future surveys. And this is really going to lay the groundwork for surveys that are coming down the line, and hopefully one day potentially even lead to the ability to distinguish between one of these technosignatures and natural astrophysical events such as planets or clouds of dust or other things around stars. And so congratulations, Dana, our first recipient this evening of the SETI Forward Award.
Thank you, everyone. I'm so excited to be here. I'm going to start off with a short story. So when I was in elementary school, I learned all about explorers like Magellan and Lewis and Clark, and I knew that I wanted to chart out new territories of my own. So I asked my teacher what parts of the Earth hadn't been discovered yet, and my life plans fell apart as I found out that most of the Earth has already been discovered. A little while later, I stumbled across a DVD set collecting dust in the closet. It was Carl Sagan's Cosmos. In the series, he talks about all sorts of astrophysical phenomena like black holes and pulsars, but always would conclude with, "We don't know." And that's when I knew I could still be an explorer. It would just have to be in outer space instead of on Earth. So I think that this idea of exploration is perfectly encapsulated by SETI. I feel really grateful to have been part of a project that incorporated so much creativity and imagination and scientific rigor. So over the summer at UC Berkeley, I worked on a project to determine the detectability of giant structures designed by aliens. It was really a project way beyond my wildest dreams. So I'm looking forward to expanding my international SETI community as I embark on a PhD at Imperial College London and a Fulbright research grant in Santiago, Chile. So I am really grateful to receive this award. Thank you. And I wanted to thank a couple people. So first is Lou Levy for being the mastermind behind this award and this incredible opportunity. I wanted to thank Dr. Steve Croft for being an incredible RU director and mentor. I wanted to thank the SETI Forward Committee for seeing something in me. And I want to thank Dr. Anne-Marie Cody and Dr. Daniel Giles, who are watching from home. Thank you for everything you've done for me. I would also like to thank all of you for being here and supporting this award and helping me achieve my dreams of being an explorer. Thank you.
Wow, so amazing, so poised. Like, I wish I was like that 2 years ago. So I'd like to present the final SETI Forward Award to Róża Okoń. She's recently a graduate from the University of Warsaw, and she is now pursuing her master's at Barcelona, University of Barcelona. Actually, her internship experience is a really interesting space, really looking at the origins of life. That's an area that's really close to my heart. And she really looked at one of the building blocks of life, which is DNA. And so when you think about DNA, there are 4 bases there. One of them is the A base, which is adenosine. And it turns out there are 2 variants of that base, 2 isomers. And she essentially, her work was looking at one of those isomers and seeing that one of them was had a very different sort of chemical composition from a photostability point of view. And so that has really profound implications in terms of the rate of evolution, especially in the early days of Earth, where there was there was likely much higher UV radiation. For this work, she was honored with the gold medal of chemistry in Poland, and she demonstrated really a profound sort of like insight in terms of this work, and really something that is at the heart of the SETI Institute in terms of really the origins of life and how it even originated on this planet. So for that work, I want to congratulate Róża and bring her up to the stage here. So thank you.
Life is a form of existence of a protein, says one of the very famous Polish poetry writer, Agnieszka Osiecka. And all of life we know on Earth is based on proteins. But I think that we can make this sentence more general, focusing on very dynamical character of life. And we can say that life is actually a form of energy transformations. And this thought hit me pretty hard during pandemics when I was about to graduate from high school, and I finally happened to have some free time in which school wasn't occupying that much my space to actually think. And I started in a scientific competition for writing an essay, and it made me dig deeper into this thought and led me into finding a very interesting field, which basically tries to answer the question about the origins of life. It made me learn about astrobiology, which existence I wasn't aware of before. And I just started digging into that. I joined Polish Society of Astrobiology. I started looking for a place for myself to start my research career, because at this point I knew that this is something I would like to do. And I found my amazing mentor, Dr. Rafał Szabla from University of Wrocław in Poland. And under his supervision, together we were exploring how the very elusive but abundant source of energy, how sunlight interacts with chemical compounds, with chemical molecules which actually constitute life. And especially, it turns out in generally that light is not only important for photosynthesis or processes which were built by life itself, but it is also very important in previous step in prebiotics, so before life, step of evolution, of chemical evolution. And we can find very interesting interactions of sunlight or ultraviolet radiation, which is part of sunlight, with both living and not living matter. And that was the area of my research. That was an area of my project. Currently, I'm doing my master's, as it is mentioned, at the University of Barcelona. I would certainly like to thank very much the committee of SETI Forward Awards. It means a lot for me because SETI-oriented research and astrobiology takes a special place in my heart. And I would like also to thank my my supervisor, both from Poland, as well as to Professor Dimitar Saselov, who hosted me at Harvard University for a couple of weeks to be able to develop my project I was working on. And yes, thank you very much for listening to me.
Congratulations. Yeah.
So it's now my pleasure to introduce Reed Spurling. Reed is a student at the University of Arizona and is receiving special recognition tonight as the 2023 SETI Institute's Summer Intern Award of Excellence recipient. Reed worked with Virginia Gulick, Chair of Planetary Sciences at the SETI Institute on a project entitled Crater-Based Surface Age Dating of Usuga Vallis on Mars. I hope I pronounced that right. Congratulations, Reed.
Right. Thank you, Lou. Good evening, everyone. I feel honored to be here. I'd like to start off by thanking everyone who made this event possible, especially the cooks and servers for providing this food for us tonight. It is delicious. Thank you. I feel really grateful to the SETI Institute for giving me the opportunity to be a part of their wonderful summer internship program led by Dr. Matt Tiscarino and Donna Richardson and enabled by all the great staff at SETI. Thank you. I'd also like to thank my mentor, Jenny Gulick, for her patience and her wisdom and for her continued support as we try to prepare our work for publication. I also want to thank all my fellow interns over the summer, the Alexes, Ella, Madigan, Maddie, Nia, my roommate, Russell, Steve, Sam, let's see, Jasmine, Fatima. I could not have asked for a better group of people to learn from and grow with. Y'all are really cool. Thank you. I also want to especially thank Dr. Rosalba Bonacorsi for leading us students over the summer on some very intensely fun field trips, including a visit to the Allen Telescope Array. Also, thank you, Rosalba, for teaching me how to speak to bugs. I would like to thank, in addition, my parents for making me and for encouraging my curiosity. I think that curiosity found a home at the SETI Institute, and I'm just incredibly grateful that this institution exists and that you have allowed me to be a part of it. Finally, I would like to thank my partner for supporting me in everything I do and for regularly asking me if I have found the sandworms on Mars yet. Hasn't happened yet, but when I do, Malcolm, you will be the first to know. Thank you all.
Thank you.
Congratulations to all the SETI Forward Award recipients. Can we give Dana, Rosa, and Reed another round of applause? They deserve it. They really do. I know that this is called the Drake Awards. It's on all of the fancy signage, and no offense, Andrew, but the SETI Forward part of the program is really the part that touches my heart the most. Clearly, all of us are here because we care about SETI and we want SETI research to have a bright future. Well, those students are that future. And there is a way for you to help fan the flames. At your tables, you'll find pledge cards that have a QR code on them, and you can use those to donate to the SETI Forward program Fund a Need. Tonight, we're hoping to double the $25,000 SETI Forward endowment. And that way we can provide future SETI researchers with more resources and more opportunities to get into this really important work. To get us started, a very generous donor has offered to match donations of $1,000 or more up to $10K. So we really have an opportunity to raise a lot of money for the SETI Forward Endowment Fund tonight. Please take a minute to fill out your pledge cards. You can drop them in the baskets at your table. And we and the SETI Forward Award recipients will really appreciate anything you can donate. Thank you so much in advance. We're going to break for about 15 minutes for dessert and for you to look at those pledge cards. And we'll be back after for another very exciting award. Yes, the pledge cards, you can write out your donation, or they have a QR code for the tech savvy people in the room. It's Silicon Valley, that's probably most of you. The tech savvy people in the room can scan the QR codes with their phone and it'll take you to a site to donate. But we'll be back in about 15 minutes, so thank you and enjoy.
Hi, everybody. I am Pablo Sobron. I am a research scientist at the SETI Institute, and my job is about looking for life and looking for resources in the solar system. My work is really looking not at the macro scale, but the micro scale. So you look at a telescope and you're looking, from here on Earth outside to a big picture. I am actually bringing microscopes to other planets so that we can look at the early signs of life at the chemical, molecular, and mineral level. So the way my work ties directly to the Drake equation is that it's giving us a pattern of how likely it is that planets or planetary bodies have hosted chemistries that are conducive to life. So in other words, we're trying to figure out how spread and how often do planets like Earth or like moons like Enceladus out there in the space, how often do those present the chemistry that life likes to harness to evolve? When I was little, I was always looking at the stars, right, and realizing that stars look so far out, but we almost can't touch them, right? And I grew up in the 80s and the 90s and in the post Apollo times, and really seemed like there was a good time to really keep digging and learning more about space. So I steer my career into really providing the technologies and the tools for us to go out and discover secrets. First, of course, in our solar system, but eventually beyond. So I got connected with the SETI Institute in the 2007, and specifically through a NASA award. And I spent summer with colleagues at SETI Institute, and I fell in love with the mission of the Institute, this drive to really explore, but tell the story, communicate the story, educate people, and make a space literate society. As soon as I had the tools to contribute to the mission, bring in some funding from NASA to continue my work, I joined SETI without thinking it twice, obviously. I think this was 10, 12 years ago. And ever since, I've really, really enjoyed being part of our ever-expanding mission to now not only look for radio signals, but look for other signs of life, which is what my work ties into, using missions to Mars, missions to Europa, Enceladus, and other planets, where we can actually dig into other aspects of this Drake equation from physical measurements on the ground. So right now, my most important project is about looking for biosignatures or life really in the ocean worlds of our solar system. For the last 4 years, we've been building, and now we have already tested and deployed this system. We built an underwater exploration robot that can find organic molecules, pigments, corals, habitats, minerals. It can do a whole suite of chemical, biological, mineralogical explorations in the ocean, not just the water, but the seafloor. So we're hoping that as the community keeps advancing new ways to visit Europa, Enceladus, and other icy moons out there, that we eventually find a way to crack through the ice of those moons and reach the ocean. For those of you who don't know, we do know now that there are oceans of liquid water in a lot of the moons of Jupiter and Saturn. The issue is what's in the water. Do we have chemicals in the water that we can tie to the presence of life, if not current life, past life in those moons? And so happens that that we think that life on Earth started in the ocean, right? In particular, in the chimneys in the bottom of the ocean that are bringing out chemicals into the ocean. So what our project did last summer is to visit some of the systems on Earth, of course, and we were able to, for the first time, to give a very in-depth picture of the chemical interactions of life, fluids, and minerals in these unique settings on Earth, so that we're learning now what we have to look for when we eventually reach the ocean worlds and deploy the same system, hopefully, to look for life out there. So I think, to me, it's a personal satisfaction, really, and personal win, being able to show this technology now on Earth. As I grew up near the ocean, and I've always questioned what's under the ocean that I cannot see. Now we can see it, right? So for the first time, we're bringing the most powerful lab, really, that can be built for underwater. Now, SETI Institute has it. We built it, we tested with NASA and NOAA and the NSF, and now we're ready to take it to a next level to explore life in other planets. The future of my line of work is really going to be defined by our ability to miniaturize systems even further, make our machines smaller so they're cheaper and easier to launch to space and to operate. We'll also be going to be driven by automation, the use of machine learning, artificial intelligence, to really equip these robots and these machines with autonomy. Think about how long it takes for signals to travel, right, between here and Mars. It's about 20 minutes, half an hour. If you're looking at oceans in Jupiter, Saturn, on the moons, you're looking at hours of delay, perhaps. So there is no joystick in these robots, right? So we need to equip them with brains. They have to be scientists themselves, right? So this miniaturization, automation, and third, and perhaps even more importantly, is about the whole context, right, of how we understand the formation of these moons, how do we understand the history of the moons, so that we can tie our observations today, I guess tomorrow, but we can tie the current observations with the past evolution of these systems. So these are the three waves, if you want, the three curves of technology innovation that we're following in my line of work. And I think this is one of the things where SETI Institute is at the forefront of the three of them. We have shown the work of some of my colleagues and myself that we can now design and build and operate payloads, instruments for doing science in space. I'm talking beyond telescopes. I'm talking about cameras, spectrometers, systems that can actually give us chemical, mineral information out there. We've proven through the FDL program and other programs, and of course, of all the radio signal processing tools developed at SETI since the beginning. We have proven that we're at the forefront, if not leading the pack, when it comes to machine learning and AI applied to signal decoding. And of course, we have a breadth of expertise across this whole scientific domains, from biology, chemistry, physics, engineering, as of lately as well, so that we can really in-house develop all these three vectors that I think are going to be the key to put SETI Institute at the forefront of exploring and finding life elsewhere, what we do. I'm unfortunately not able to be there with you today, but I want to make sure to congratulate our winners of this year, Andrew and Frank. One of the things that I like about their work is that it really expands at both ends of the spectrum of energy. While Andrew is looking at radio, right, all the long signals and far distances out there, Frank is now looking at the optical part of the spectrum. He's looking at what's happening that we can see, right, in the visible, a little bit of the UV and infrared as well spectrum. So if you can imagine, we're covering now a much broader spectrum of the electromagnetic spectrum, right, of the physics of the universe as we know them. And I think having these two impressive scientists now being recognized for their work to advance our mission, I think it's really again a testament to how good we're doing science, how the contributions of our scientists are really pushing science and technology for everybody in the world. And I couldn't be happier to have our winners today being celebrated. But I don't want to forget also the younger generations. And this year we have two SETI Forward Undergraduate Awards as well. And I want to congratulate them too, as they are the future generation of scientists that most likely will be the ones who will find life elsewhere. So I will join you virtually in celebrating our awardees today. And I look forward for a big party next time I visit everybody out in the Bay. Bye, everybody.
Hello, everyone, and welcome to the Drake Awards. My name is Dr. Sofia Sheikh. I am an NSF Ascend postdoctoral fellow working at the SETI Institute on the Allen Telescope Array at the Hat Creek Radio Observatory. So I'm a radio astronomer, primarily working on SETI and radio technosignature searches, but also everything else in radio astronomy. So fast radio bursts, pulsars, tracking down radio frequency interference, all sorts of fun things at the Allen Telescope Array. I think the Drake Awards are such a unique opportunity within the field of astrobiology, and especially within SETI, as one of the few ways that we have to really award people whose entire careers, either at their start or kind of as they've progressed, have really changed the way that we think about life in the universe, and a way to recognize all of these amazing achievements that sometimes go unnoticed, even with people just, toiling and spending all of this time working towards this amazing goal. So it's wonderful to take the time to actually recognize that. In my work at the ATA, I've been recently doing a lot of work on fast radio bursts. So trying to understand where these super bright pulses of radio energy come from and what could be causing them. Probably some sort of compact object like magnetars, but that's the sort of work that we're doing at the ATA to understand the progenitors of these sorts of events. I've also been doing, of course, a lot of SETI. So we're hoping to start a project sometime probably in the next couple months where we survey the anti-solar point. So this is looking at stars which, from their perspective, can see the Earth transit the sun once a year, and observing them at that kind of special alignment time when our star, the sun, and the Earth are all aligned, because it might be a better than average time to search for coordinated signals from extraterrestrial intelligences. I think if you talk to anyone in the field of SETI, they'll tell you that this is the most exciting time that the field has ever had. We have the capability now with kind of new and upcoming instruments like the Allen Telescope Array and all of these other facilities coming up around the world to really be surveying much more of the sky at many more frequencies simultaneously, looking at many more targets, and just doing much more SETI, covering much more of the sky than we could ever do before. That's kind of the most exciting thing for me, is just seeing how many instruments, how many people are getting involved in the search so that we can actually start making a dent in the cosmic haystack and start to be able to say things more quantitatively and concretely about the distribution of technological life in the galaxy. I'm really happy to be a part of this event, even just through this recording, and I'm really happy to get to congratulate our SETI Forward winners, our undergraduates, as well as Franck Marchis and Andrew Siemion on their awards today. I would not be here at the SETI Institute doing SETI work, which is somewhat of a dream come true for an astronomy student, if not for Andrew Siemion kind of giving me a chance to get started on this work in undergraduate at Berkeley. So very special to me that he's getting recognized today. And I'm looking forward to a great event.
All right. Hello, everyone. If I could get your attention. It is the moment of the evening that I think we've all been waiting for. It's time for the titular Drake Award, finally. Woo! This award recognizes, hello, Bill.
Hello, Moiya.
This award recognizes exemplary contributions to SETI or to astrobiology through scientific research and space exploration. And this year, the award has been sponsored by Breakthrough Listen. So thank you, Breakthrough Listen, for sponsoring. We can give them a round of applause. Tonight's recipient will be the 10th member of a very prestigious club that includes the great Franck Drake himself. I can't wait to hear more about his work. And so I'm just going to step away and let Bill Diamond introduce this year's Drake Award recipient.
All right. Thank you, Moiya. So I hope everybody's had a little refreshment this evening and been nourished and thirst quenched and all the rest. But this is the ultimate part of the ceremony, the Drake Award ceremony itself and the Drake Award presentation. Before we get to that, I'd like to, since this is about celebration, this whole night is about celebration. It's about celebrating science. It's about celebrating the people who do science and support science. And that includes all of you. So I'd like to thank and celebrate all of you for sharing your night with us. You came, you bought tickets, you sponsored tables, you came as guests, but you carved out time to be with us here tonight. And I want to thank all of you and celebrate you too. So thank you very much. Also, I want to remind everybody that at the front of the room where you came in, we have a table that has lots of fun give out away things, including postcards of the Drake equation, so that nobody can leave here tonight saying they're not familiar with the Drake equation. That is sort of de rigueur knowledge in order to attend our events. And there's bookmarks and stickers. And if you'd like to buy a hat or t-shirt, those are available too. And of course, we'd love to get photos sent to us from all over the world, people wearing their SETI hat at the top of the Eiffel Tower and things like that. So you won't want to miss that opportunity. And I do hope that you've given consideration at least to the prospect of supporting the SETI Forward Award with your support and contributions tonight. It's important for you to know that not one penny of that goes to the Institute itself. Everything is there and put aside an endowment to support the students themselves. And I think that's very important because they are the ones we want to honor. They're the ones whose careers and passions and futures we want to support. So thank you very much for those of you who've contributed to that wonderful program tonight. All right. So here we are off and running. I want to tell you a little bit about the Drake Award. So the SETI Institute's Drake Award celebrates exemplary contributions to SETI and astrobiology through scientific research and space exploration. The award honors, of course, Franck Drake, whose Drake equation, back of the room, everybody take one, first identified the specific factors necessary for the emergence of life in the universe and the evolution of technological civilizations. This honor is given at the discretion of the Board of Trustees of the SETI Institute based on nominations from its Science Advisory Board. Again, a couple of members which are here with us tonight. The honoree is presented with a cash award and a medal and certificate and is invited to describe their research at a public ceremony, this ceremony. So the award was initially presented to Franck Drake in 2001. It was followed by Nobel laureate and inventor of the laser, Charles Townes, in 2002. Other recipients include the Bay Area's own Bill Barucki, who couldn't be with us here tonight, but Bill is a NASA Ames scientist who proposed and led the Kepler mission. How many people are here familiar with the Kepler mission from NASA? Almost everybody. To me, it remains one of the most profound and significant science missions in NASA's history because it taught us something profound and deeply inspiring, and that is that planets are ubiquitous in the universe, that when you look up at the sky on a starry night, you're seeing not stars, but solar systems. So Bill Barucki was the head of that mission, and the Institute was a proud participant in that mission, managing the data pipeline for the Kepler mission and also writing the algorithms for the planet detection in the light curves of the Kepler data sets. So we also have with us tonight a previous recipient of the award, whose name is John Rummel, who received the award last year. John, are you with this? I know that there he is. I know he has to leave pretty soon for Chicago, but Dr. John Rummel has a career that spanned activities in cross domains, including SETI and astrobiology and planetary protection. Also with us tonight is the 2019 recipient, Dr. Jason Wright, who's a radio astronomer and SETI researcher at Penn State. Jason, can you stand up? And with us also tonight is Dr. Dan Wertheimer, another radio astronomer and SETI pioneer from UC Berkeley. And Dan, would you stand up and be recognized? 2021 recipient. It's great to have Dan here, and Jason and John. So this year, the Drake Award honor stays close to home. It's recognizing the extraordinary achievements, contributions, and leadership to the world of radio astronomy SETI from an individual who not only leads the SETI Research Division at the SETI Institute as its Bernard M. Oliver Chair of SETI Research, but he directs the seminal Breakthrough Listen SETI Research Initiative. So early career is a relative term, of course I know, but from my perspective, pretty much everybody is early career. But Andrew is early career. This is a young man who is, as a young researcher, has had an extraordinary impact on the field of SETI, and he's already cemented his place at the top of this field on par with its early pioneers and innovators. I have two special guests who are going to join me in presenting the award to Andrew tonight. And the first is the chair of the Board of Trustees of the SETI Institute, none other than Dan Langford. So Dan, come on up. It's also an honor and privilege to have with us tonight Dr. Pete Worden. Pete is going to join us up here as well to present the award. Pete is a 3-star general from the United States Air Force, the past director of the NASA Ames Research, and the current president and chairman of the Breakthrough Prize Foundation. So it's so wonderful to have Pete with us tonight. Dan?
Well, I'll shake hands with
you. You do. Absolutely. All right. What we'd like to do now is, in his own words, let you meet Andrew Siemion.
The Drake equation, the golden record, the Arecibo message, they all have one thing in common, and that is Frank Drake was behind them. Frank Drake was an extraordinary radio astronomer, Harvard and Cornell educated scientist, and really the father of SETI as an endeavor, having undertaken the very first SETI experiment in human history, and arguably, through the Drake equation, the father of astrobiology. The Drake Awards was conceived as a way to recognize people in the field of SETI, and more broadly astrobiology, to recognize people who've made significant contributions to this field, this endeavor of trying to answer this question, are we alone? Are we alone in the universe?
So Andrew's a good candidate for the Drake Awards because he really inherits the passion that Frank Drake himself had for this real fundamental question that we've been asking ourselves since time immemorial. Are we alone in the universe? And Andrew is really building a team and putting together the equipment and the telescopes and the data and the people that we're going to need to answer this question. I know that Frank himself was proud of the work that Andrew was doing, and I think he's carrying his legacy forward.
I mean, I can't think of anyone more deserving for the Drake Award than Andrew Siemion. His work leading to these huge SETI surveys, these multinational collaborations and projects that have really kind of pushed forward the boundaries, setting new upper limits, moving forward into new parameter space for SETI that was not even like imagined or dreamed possible kind of 10, 15 years ago.
Andrew is really driven. He's very energetic. He has a global view of the importance of SETI and of the instruments that we're using.
Modern SETI would not be what it is today without Andrew. Something I like to say, science is a human endeavor. And Andrew is so good at the human side of that endeavor, just bringing people together, building collaborations, bringing that necessary organization and leadership, without which none of the kind of amazing scientific products of Breakthrough Listen or the SETI Institute would be possible.
Well, we're delighted this year to be honoring and recognizing Andrew Siemion as the 2024 recipient of the Drake Award. And Andrew, I would say, has been one of the more transformative and impactful figures in the field of SETI in, say, the last 5 or 10 years.
I'm, certainly very, very happy to see all the advances that have happened in SETI and in the search for technosignatures, and whatever small part I've played in that. I'm happy to try to continue Frank's legacy of helping to move forward the entire field. If you look up at the night sky and you get the goosebumps and you want to know the answer, then find it, seek it out.
So I have a confession to make, which is I hadn't seen that video yet, because otherwise I would have said in my words and Steve Croft's words and Sophia's words and in Andrew's words. But I think this video tribute pays appropriate homage to Andrew and his extraordinary contributions, and we're delighted to be recognizing him here tonight. So Andrew, would you please come forward? By the way, I've never seen a smile on Andrew as big as those pictures with him wearing a hard hat out with the telescopes and this Cheshire cat grin on his face. That's a happy scientist. So Andrew, we're here to present you tonight with the medal.
Solid gold.
Solid gold as our 2024 Drake Award recipient. And I'll hold that box. All right.
Kind of heavy. There you go. Okay, let's put solid heavy. Congratulations. Thank you.
And we have the official certificate of the Drake Award presentation for you, presented by Pete.
Congratulations.
And last but not least, Andrew, a check for $25,000 to continue your extraordinary work. Ladies and gentlemen, let's hear it for Andrew Siemion, the 2024 Drake Award recipient. And we'll now turn the podium over to Andrew to tell you a little bit about his work, and we should have you home by midnight. All right.
Thank you very much, Bill, Dan, and Pete. I'm humbled and honored to receive this award. I have to start with a little bit of a confession of sorts. So this award said that it was sponsored by Breakthrough Listen. I am the principal investigator of Breakthrough Listen. But I promise you, I had absolutely no role in the selection of the awardee. Hopefully you'll believe that. I'd like to start with some thank yous to a few people. First to the staff and the scientists and the leadership of the SETI Institute, its board of directors, its science advisory board, and its supporters. All of you are a deep source of knowledge and inspiration to me. And thanks especially to my colleagues at the Hat Creek Radio Observatory, many of them are over here on this side of the table, who have transformed the Allen Telescope Array over the last handful of years
from a collection of novel technologies to a world-class observatory. Thank you also to my colleagues at the Breakthrough Initiatives for taking a chance on a few newly minted postdocs and engineers to lead the Breakthrough Listen program, and especially to our program officer, Jamie Drew, who's here tonight, who has become both an invaluable member of the Listen science team, as well as a close personal friend. To all of the past, present, and present researchers, students, and staff of the Breakthrough Listen program, thank you for your dedication and perseverance in manifesting the most comprehensive, sensitive, and intensive search for extraterrestrial intelligence in history. And especially to employee number 7, it took me a while to calculate that, Steve Croft, who has led the development of our undergraduate research program spectacularly, that has now exposed more than 200 early career researchers, largely undergraduate students, to state-of-the-art technosignature research. My postdoctoral advisor, Mike Garrett, is also here tonight, both as a member of the SETI Institute Advisory Board, as well as the Advisory Committee of the Breakthrough Listen Initiative. For over a decade, Mike has been a mentor and a friend, an occasional happy hour companion, and a frequent co-conspirator in bringing the technosignature field into productive alignment with academic astronomy. Also, a round of applause for Professor Garrett, who today was announced as an elected Fellow of the Royal Society in the United Kingdom. I'd also like to offer very special thanks to the visionary private benefactors of our research programs who have kept the lights on in the darkest hours and ultimately fueled the tremendous revolution that we see now in the field, including Julia and Yuri Milner, Carol and John Andrea, and Franklin Antonio. Finally, and most importantly, to my wife, for your unending love and support. In addition to being my partner in all things, Maichi also served as principal investigator in the one successful search for life I have been involved in, the birth of our 2 daughters. So with that, I'd like to talk a little bit about the search for extraterrestrial intelligence. The image that you see here on the slide is one of my favorite images in all of astronomy and astrophysics. Many of you have probably seen it before. It's one of a series of images made by the Hubble telescope. This is the Hubble Extreme Ultra Deep Field, this particular one. And it was made by taking the Hubble telescope, one of the most powerful telescopes that we have, and pointing it at a very small patch of sky for hundreds of hours. It's about the size of a pin held up at arm's length, and producing a very, very deep image. And every point of light that you see here, the small ones and the big ones, are not stars, but are actually galaxies. And from this image and other images like this, we can actually count up all of the galaxies that we can see in the observable part of the universe. And there's something like 1 trillion galaxies that we can see, each one of those galaxies with a trillion stars, which is an amazing number, a trillion stars. But it actually belies an even more amazing fact about the universe that we know of, that there's actually more planets in the night sky than there are stars. The average number of planets per star is greater than 1. There are nearly innumerable planets just in the part of the universe that we can see. And on at least one of those planets, the same laws of physics that guided the formation of the first galaxies and the formation of planets and other solar systems, our own and others, those same laws of physics gave rise to a remarkable phenomena, the phenomena of life. And that life went on to develop fantastic complexity. And a few 100,000 years ago, a form of life, Homo sapiens, us, came about on our own planet and ultimately developed a technological capacity, a capacity to ask questions about the universe that gave rise to them, a capacity to explore the universe in remarkable ways, to study it in great detail, to learn about its past and perhaps its future, and ultimately to extend life beyond the planet where life began into the rest of the universe and at least the rest of the solar system and perhaps soon further than our own solar system. But of course, the question that everyone is here to ask, and that hopefully some of us are going to answer in the near future, is are we alone? In that vast dark forest that we see in front of us, is there any other life? And for the moment, we don't know the answer to that question. And for most of the 100,000s of years that we've existed on this planet and been asking that question, we haven't had any way to answer it. But over the last 10 years, some remarkable developments have happened in the field of the search for extraterrestrial intelligence that gives us great hope for being able to answer that question in the near future. One of the most significant occurrences in the recent history of SETI was the announcement of the Breakthrough Listen program. This was announced in 2015 at the Royal Society in London by its principal sponsor, Yuri Milner, joined by Stephen Hawking, Martin Rees, Frank Drake, Andrew Druyan, and others, which was an effort, a concerted effort, funded by a substantial amount of money, $100 million, to engage the entire planet, engage the entire world to try to answer this question, to create a global collaboration, a global effort involving not just scientists, but engineers, data analysts, the public at large, to try to answer this question. And just last year, we announced that the Breakthrough Listen program would move to the University of Oxford. So the Breakthrough Listen program is now headquartered in the United Kingdom. Now, the University of Oxford is a fantastic institution. It's one of the oldest universities in the world. It's a premier university, to be sure, but it's also not in the Bay Area, which is very important. SETI for many, many years has had a kind of a nest in the Bay Area and been able to perhaps exist in a very special environment, but struggled to find a foothold elsewhere. And with Breakthrough Listen's move to the University of Oxford, for the first time, we will have a major SETI effort headquartered outside of the Bay Area, which really will open up and is opening up the rest of the world to SETI research. Another very important figure in the recent history of SETI is Franklin Antonio. Franklin Antonio began funding SETI research at the SETI Institute around 15 years ago or so. I met him in 2018, and together with Bill, we conspired to a plan to try to bring the Allen Telescope Array back to what we knew that it could be. And since 2018, the Hat Creek Radio Observatory team, as I said, have transformed this facility immeasurably and taken it from really just a collection of interesting technological marvels to truly a world-class observatory. Just today, the Allen Telescope Array was one of the first telescopes in the world to follow up on some candidate Dyson spheres that were announced just a few days ago in the astrophysical literature. Some of you may have seen this paper. And this is the power of having access to your own observatory. You don't need to ask anyone's permission. You don't need to schedule the time. You simply phone up Wael Farah here and ask him to point the telescope at something, and he does it, which is a remarkable capability, but also remarkable that the telescope is in the state to be able to conduct excellent scientific observations at really a moment's notice. The Allen Telescope Array now joins a suite of telescopes that are undertaking technosignature searches. We've arrived at a stage in the search for extraterrestrial intelligence where the majority of the world's major observatories are participating in the technosignature search. Radio telescopes, optical telescopes, high-energy telescopes, space-based telescopes, all of them exploring a slightly different piece of parameter space, helping us to constrain the parameter space of extraterrestrial artificial signals in ways that we never could have in the past. And these telescopes are incredibly powerful. They're conducting incredible searches. They're wonderful facilities, but even these pale in comparison to what's coming in the next 10 or 20 years. Soon, the Vera Rubin Observatory in Chile will see first light. This is a revolutionary wide field optical telescope that will conduct surveys of the entire southern sky once a week for a decade. This telescope will uncover many, many dozens, eventually hundreds of interstellar objects. It will allow us to see billions of stars and billions of galaxies that we've never seen before. And very importantly, we'll have powerful anomaly detection algorithms built into the data pipeline that allow us to find new phenomena, anomalous phenomena that we can't even dream of. This is a discovery machine, not just for technosignatures, but also for astrophysics at large. And we're incredibly excited that we'll be partnering with the Rubin Observatory to conduct some excellent technosignature searches. On the radio side, the Square Kilometer Array is already under construction. This is a telescope that will eventually have a full square kilometer of collecting area. It's being constructed in 2 places, in South Africa, as well as in Western Australia. There's a mid-frequency portion, which is in South Africa, a lower frequency portion in Western Australia. And the really, I think, most important thing about the SKA, in addition to the fact that the search for technosignatures is a fundamental part of its science case, which itself is novel, this is the first telescope in the world that would be sensitive to leakage level radiation from a nearby human-like civilization. So the truth is that most of the telescopes that we use now, most of the observing programs that we do, would not be sensitive to things like TV transmissions if they were emitted even from the nearest stars. But the Square Kilometer Array will have enough collecting area to be able to detect those kinds of transmissions, and we'll be able to constrain explicitly the distribution of human-like civilizations around the stars nearest to our own sun. Here in the United States, the next generation VLA is in the planning stages. We hope that construction will begin in the next 5 to 10 years. This is going to take the VLA, already a very powerful telescope in the American Southwest, and increase its sensitivity, its angular resolution, its frequency coverage by a factor of 10. An incredibly powerful instrument. And conveniently, the SETI Institute already has a Pathfinder program called COSMIC, which is operating now on the Very Large Array in New Mexico. And there's kind of a clever trick that you can play with a radio telescope that's unique to radio astronomy, and that you can actually take a copy of the data that the telescope is seeing before anybody does anything with it and feed it into your own signal processor to search for whatever kind of signal you like, in our case, technosignatures, with no loss of sensitivity to the primary observer. So what that means is that we can conduct a SETI search 24 hours a day, 7 days a week, alongside anything this telescope is doing. And a lot of telescopes do sky surveys, which, as it turns out, is exactly the kind of thing that we're interested in doing. The COSMIC program has been operating on the VLA for just about 2 years now, and it's already observed more than 1 million stars. This is 3 orders of magnitude more stars than have ever been observed in this way with any single dish facility. An incredibly powerful technosignature search machine. And again, importantly, lays the groundwork for future searches on the next generation VLA and the Square Kilometer Array. And we have a lot of stars to look at. This is the Gaia satellite, which is mapping out the location of objects in our own solar system, as well as stars in our own Milky Way galaxy. This graphic that you see here that looks very much like an image of the Milky Way galaxy, perhaps you've seen before, is not an image at all. It's actually a map of almost 2 billion stars that the Gaia satellite has cataloged. So we've observed about 1 million or so, as I said, with cosmic. We have about 3 more orders of magnitude to go to get to 1 billion. But we have the data to target them. We know where the stars are. And this is a fantastic asset for our searches with the cosmic system and, of course, with the SKA and the VLA. But also is a fantastic asset for all kinds of data-driven astronomy, because if we know where the stars are, we can look for things that are associated with stars. And we know that all stars have exoplanet systems. An incredible asset that we're just beginning to tap into in the technosignature search. We're also leveraging the power of machine learning and artificial intelligence. And we're just scratching the surface of what will ultimately be possible by framing the problems that we have in the technosignature search in a way that's amenable to using modern ML and AI algorithms. It also allows us to leverage the hardware accelerators that are making those algorithms run very, very quickly, enabling us to look at more bandwidth, more sensitively, for a much wider class of signals. And we're also seeing fantastic developments in space exploration generally. I think we're in a new Apollo era. We're in a new renaissance of space exploration with many, many companies operating all around the space ecosystem, both developing launch capabilities as well as other kinds of technologies that are useful for astronomy. And this does a number of things for the technosignature search. One, it allows us to put very, very powerful instruments, very sensitive instruments, inexpensively into space. Space is a better place to do astronomy, full stop. It's typically very expensive, but with things like Starship and other launch vehicles that are reducing the cost for launch, it's going to enable us to put incredible instruments into space, perhaps even on the far side of the moon in the near future. It also informs us about the possibility for intelligent life to spread beyond the planet that gave rise to it. It gives us new knowledge about the way in which technological civilizations might be detected, the way in which a technological civilization might use other planets in its own solar system in order to further its own existence. And all of these things combine to really bring about an incredible new era and new research directions in the search for extraterrestrial intelligence. So in closing, I'd just like to say a couple of words about Franck. I feel incredibly fortunate to have had the chance to get to know Franck over the last decade or so. And he was an incredible scientist, an incredible friend to me. And something that is not often, I think, stated about Franck, but I think is very important to state, is that his scientific excellence was really outmatched actually by an incredible generosity of spirit. He was incredibly kind, both as a person as well as a colleague. And as many of you perhaps know, that's not a trait that is necessarily universal in science or really in any field, but it was a wonderful inspiration to me, continues to serve as an inspiration to me. And I have to say I'm, really without words to describe how happy I am to have the chance to continue to contribute to the field that Franck started. And it's bittersweet to receive this award. But at the same time, I know that Franck would be incredibly happy about where the field has come already, and incredibly excited about the future that we have before us. Thank you.
That was great. Thank you so much. Congratulations again to Andrew. I just got so lost in that talk because I was so excited about your science, and then I completely forgot that I had to come back on stage. But I would also like to invite all of tonight's award recipients back on stage. So Dana, Róża, Reed, Franck, Andrew's already here. Everyone, if you've been on the stage tonight, please come back so we can all get a picture together. We've reached the end of the evening, everyone. You've been an amazing audience, but we have some final words for you that I believe Bill would like to deliver.
All right. Well, thank you, Moiya. How about a hand for our amazing MC? And as a small token of our huge appreciation, a little bag of goodies for you.
Thank you. I love
from all of
goodies.
us.
Oh, thanks.
Thank you, Moiya. All right. So why do we do SETI? What is the point? I think there's at least two. But one is that SETI as an endeavor is something we consider to be a hopeful endeavor. The statistical probability of the type of advanced civilization we might find as we search the cosmos is that it's likely to be far older and more advanced than we are. And why is that true? Because the probability of two 100-year-old technological civilizations finding each other is probably close to zero. So if we find life beyond Earth, it's likely to be far more advanced and far older as a civilization than we are. And what does that mean? What does that imply? Well, from my perspective, one of the implications of that is, the human species on this planet is the first species to, through its own actions, do such harm and damage to its own environment that our long-term future is actually somewhat in question. So if we can find evidence of civilizations that have passed through their technological adolescence and come out the other side, my personal belief is they only were able to do that by coming together, by uniting, and by seeing that they had a society which depended on cooperation and coordination of activities. So we're either going to get that right, or we're not going to be around to be found by somebody else. So that's why we think SETI is such a hopeful endeavor. And also, I would say the second thing that is so profound from my perspective about SETI is that SETI is also, as Jill Tarter beautifully puts it, it's like holding a mirror up to ourselves, because we are the example of life, and life on this planet is the example of life that is the only place we can study in terms of looking for life elsewhere and also imagining life as we don't know it. So from that perspective, from the sense of getting to know ourselves better and our place in the cosmos, I think SETI is also inspiring and important. So those are the reasons we do SETI. These are the people who do SETI, and we thank you so much, and we're so grateful and to be able to honor you all tonight. So. Now, as Moiya will tell us, we usually have some final words that are among the most important that are shared with us every time we do the Drake Award celebration. And Moiya, who was that last year?
Yeah, so last year was the first award ceremony after Frank's passing, and his daughters, Nadia and Lila, were kind enough to come and deliver the final words from the stage. But this year we have a fun surprise for you.
All right. So, in fact, Nadia just texted me a little while ago to congratulate Andrew and this year's award recipients and say hello to all of you. So she wasn't able to be with us tonight because she's getting married soon, which is very exciting. But in any case, tonight, we're going to let somebody else have the closing words. And that is somebody who also traditionally had the closing words on the Drake Award ceremony. And so I'd like to ask everybody to remain as quiet as possible while we let Frank Drake himself have the closing words tonight.
Optimism about how our technology will keep us visible, either through radio or light waves, makes me use the number 10,000, in which case N is 10,000. Now that's a good number. Lots of civilization to detect if you believe it. Now, of course, I've told you how uncertain that number is, but it doesn't make the search easy. 10,000 civilizations out there. And last night when I was talking about Jill, I mentioned those are all the finish lines in the galaxy. There are 10,000 places you could arrive at and find a civilization. But that means only 1 in every 10 million stars has a detectable civilization. So there are lots of them, but it will take a lot of searching. And this is the big challenge to our SETI program. why we need to do much more than we do, why we need much more money, because we need to search literally millions of stars before we'll have a high probability of succeeding. Now, we may luck out, you know, people do win the lottery by buying 2 tickets or so, but, and what we're doing here is really playing the lottery. We're searching, and every time we search, we're buying a ticket in the lottery, but the chances of winning in any given ticket is less than 1 in 10 million. 1 in 10 million, which is what we're dealing with. And you may ask, oh boy, why do you even spend your time on this? And the reason is, and there's a good reason, that we know that the detection of extraterrestrial life will so enrich our civilization in many ways, sociologically, technically, theologically, everything important to us, that it's worth buying all the lottery tickets it will take to win the lottery.
All right. So sign up for your lottery tickets. Come along on the journey with us. And we're so, again, appreciative and delighted that you could be with us here tonight to join in this celebration, to come along on this celebration of science and the scientists and people behind the scenes who make it all possible. It is a journey of discovery. We think it's the journey of ultimate discovery. And as Frank himself put it, the discovery of life beyond Earth would be one of the most profound moments in human history. And you're here with some of the people who may make that discovery. Exciting times indeed. These are perhaps among the most profound and exciting times in history for this kind of work. As Andrew pointed out, for most of human history, we haven't had the tools to do it. The question about life beyond Earth was relegated to philosophy and religion. Now, what's different is we actually have the tools and technology to answer that question, and those tools and technologies are getting more and more powerful and more extraordinary with each passing year. So maybe the moment is upon us, and maybe the moment is soon. But again, thank you all so much for being here. A round of applause for all of you, for our award recipients, our table sponsors, the wonderful staff here, and servers and cooks at the Computer History Museum. Please join us again next year. Keep in mind November 20th, 2024, as our 40th anniversary. We'll be having what I hope will be a hell of a party. And we may even have more things to celebrate than our 40th anniversary, who knows? But thanks again so much for coming. Everybody, please get home safely and come along and join the SETI Institute in the ride of a lifetime. Thank you and good night, everybody.
Any closing remarks, Seth?
Well, I had some, but I don't know if it pays to even say them now. You think so? They're not listening at this point.
Well, go ahead and thank everybody for being here.
All right. Yes, this is Seth Shostak, and I'm actually on the schedule for now, but I'm not going to keep you from going home, only to say that keep in mind something that was implicit in what Bill Diamond just said, and that is you are very fortunate to be the first members of the first generation. There have been 10,000 generations of Homo sapiens before you, but you're among the first that has the opportunity, the technology, and the knowledge to find company in the cosmos. Good night, everybody.